Hi everyone, hope all are doing good. Now we are going to second topic of our first unit, stress and diagram. In this session, I will like to discuss what do you mean by modulus of elasticity and stress and diagram for mild steel and what do you mean by modulus of rigidity. So first, modulus of elasticity. Elastic materials are always spring back into the shape when the load is released. This also called obeys Hooke's law. So now first what you shall discuss what do you mean by Hooke's law. Hooke's law states that within the elastic limit, the stress is directly proportional to strain. So when we consider a spring, so the deformation of the force by deformation is nothing but stiffness and it is directly proportional to the applied forces. The stiffness is different from material to material and size to size of the material. So if F is the force applied and X is the refer as direct stress and strain, then we know that force stress is equal to load by area. So force is equal to or load is equal to, we can write it as sigma into A, and where X is change in length by original length. So that is L. So F by X is equal to sigma A into EL. So now it is shortly termed as FL A by AX is equal to sigma by E. So this sigma by E is nothing but stress by strain and it is called as modulus of elasticity and its units are Newton per meter square or Newton per mm square. And if you draw the curve within the elastic limit, the stress so will be a straight line. Within the force applied with the strain, it will be a graphically straight line. I hope everyone is clear. So now we'll go with stress and diagram for mild steel. So first, how to conduct the experiment on a mild UTM. So first, you will be taking a mild steel specimen and it will be placed in UTM, Universal Testing Machine. So once you apply the load on the mild steel material, what will happen if it starts, if the load is 0, so it starts linearly up to this point, and this point is called as proportional limit. Up to this limit, it gradually the stress will be directly proportional to the applied strain. So up to this point, this is called as elastic behavior, and the curve will be in a straight line, and the materials are elastic. And this point is called as proportionality limit. At this proportionality limit, upper limit up till upper limit, it will be a linear line, and the material responds still elastically. The curve tends to bend and fallen out after once you reach cross the elastic region. Okay. Next, after this point, if you further increase the load, then the point is called as yield point or yield stress. So after increasing of load within the elastic limit, it will not be breakdown with the material caused on deforming permanently. That behavior is called as yield point, and that point is called as yield point, where the plastic deformation starts and the material is in perfectly plastic. If you further increase, it will maintain constantly and perfectly plastic yielding. After that, it will be going to a point called as strain hardening, and the further increase of load, it will goes to a maximum point of ultimate. Ultimate is nothing but till that position, it will be okay. After that, it may at any moment it may chances for failure. So what do you mean by straight hardening? We'll discuss. So within the yielding has ended, the load applied, the resulting in curve rises continuously become flat when reached the ultimate stresses. While specimen is elongating, its cross-sectional area will be decreasing and fairly uniform. After that point, it is forming as a necked region and the slip plans within the material and the shear strain as a result of neck tends for smaller area and the specimen started called as fracture stresses. So after this particular point, if you further increase load, it will be fractured. Once, if the material has broken and it will be the structure of cup and cone, the specimen will be break up into cup and cone structure. I will show you the in the class. I will bring the mild steel specimen, and after the applying of load, how it has breaken also will show. So this is regarding stress strain diagram for mild steel. So next, what do you mean by modulus of rigidity? In general definition, modulus of elasticity is nothing but normal stress by normal strain, whereas in modulus of rigidity, it is nothing but shear stress by shear strain. And for that simple explanation, like similarly taking a spring an example, and within the load, F of by x is constant. So, and this is called as shear stress by shear strain is called as modulus of rigidity. So now we shall solve one problem, one or two problems, and then we'll end up the session. So a metal wire is 2.5 mm diameter and 2 meter long. A force of 12 Newton is applied on it and stretches 0.3 mm. Assume material is elastic. Determine the following: stress in the wire, strain in the wire. So he has given the diameter as 2.5 mm. So and length is 2 mm, and the force applied is 12. So and it stretches up to 0.3 mm, which means once you apply the load, it stretches 0.3 mm. So he asked us to find the stress. We all know that stress is nothing but load by area. So here the load is given as 12 newtons. So as it is a wire, the area of cross-sectional area will be pi by 4 d square. So it is in mm. I will convert into meters. So d 2.5 into 10 power. Here I solved it in mm. So the area is 4.9 into 0.09, and sigma is equal to F by A. F is given as 12 by 4. So the stress is 2.44 Newton per mm square. And we have asked us to find out the strain. Strain is nothing but change in length by original length. What he said, the change is it stretches up to only 0.3 mm. So the change in is 0.3 and the original length is 2 meters. I'll convert into mm. So it is 2000. So 0.3 by 2000, that is 0.0015, and does not have any unit strain. I hope it is easy. Similarly, you solve one more example. So short answer: sample of modified modulus of elasticity, rigidity. Explain the stress strain diagram for mild steel in each stage. Thank you.